Hello, and welcome to another digital lecture for Salt Lake Community College. This lecture will continue to cover section 4.1 for Introduction to Statistics, examining quantitative data. There are only a few definitions in this section that we would like to be comfortable with when examining quantitative data, or more accurately, when we're wanting to describe quantitative data. The first is our definition of center. Recall that we use the center to describe a middle, a typical, or an average value in our data set. Usually, we use the mean when we want to describe the center. The second is variability. Variability discusses how consistent the data are. If we were talking about the ages of people that we would see in a supermarket, are they between the ages of 18 and 22? Pretty consistent. Or are they between the ages of 18 and 55, where there is much more variability in their age? We also would like to be familiar with deviation. Deviation is going to be the distance of an observation from its mean. If I were to write the deviation as a formula, it could be written as your observed value minus the mean, or written as xi, representing your observed value, minus x bar. The next is variance. Variance roughly is the average squared distance from the mean. And then lastly, the standard deviation. The standard deviation is the square root of the variance, which describes how close the data are to the mean on average. We will look at calculating each of these statistics in an example, but right now let's focus on how standard deviation describes variability. Later, we'll look at examples where we will calculate this using formulas. Also recall that for bell-shaped distributions, that we know about 68% of the data will be within one standard deviation of the mean, and about 95% of our data will be within two standard deviations of the mean. Recall we looked at this when we were discussing the empirical rule. And also recall that those percentages do not hold for distributions that are not bell-shaped. Again, let's focus on standard deviation for a moment though. And consider this example that discusses the restaurant wait times at two different restaurants. The histograms below show the distribution of wait times to be seated for a random sample of customers at two different restaurants. What is the mean wait time for each restaurant? So remember, your mean for a histogram can be seen by your most typical value. And visually we can say that for both of these restaurants, the mean is approximately 8 minutes. which restaurant has a more consistent wait time? Now this is where we're talking about variation or variability. What you'd like to notice is that with restaurant A, the wait time will vary between what appears to be 1 minute and maybe around 14 or 15 minutes. While for restaurant B, it appears that your wait times to be seated might be somewhere between 7 minutes and 9 minutes. So much more consistent, less variability. So we can say that restaurant B is more consistent. There's less variation in restaurants B's wait times. And lastly, which restaurant would you consider to choose if you were in a hurry? Now, there's no one right answer here, but one could make an argument that at restaurant B, you will more consistently be seated between 7 to 9 minutes, while in restaurant A, it could be as little as 1 minute or as long as 14 minutes. And so if you were in a hurry, you could make the argument that a more consistent expected wait time might be preferred. If you were a gambling person, you could say that you could sit in restaurant A and be seated as little as 1 minute, which would be really nice if you were in a hurry. But it could take as long as 14 minutes, and if you were in a hurry, this might not be preferred. Let's look at a couple more definitions. The first is going to be another graphic for describing quantitative data called a box plot. A box plot is a graph for quantitative data that summarizes the data using 5 statistics while also plotting unusual values. We will look at creating a box plot in another example, but for now I'd like to show you a visualization of what a box plot is. One of the values that we will use in creating a box plot is referred to as the median. And the median is used to describe the center. It splits the data in half. When looking at a median in a box plot, you'd like to know that your median is this middle value. It makes it so that 50% of your data lives above that value and 50% of your data lives below that value. Formally, we can say that the median is the number in the middle, so that if the data are ordered from the smallest value to the largest value, you have to write your data in order. Then the median is the observation right in the middle. If there are an even number of observations, so like 2, 4, 6, or 8 data points, an even number, then there will actually be 2 values in the middle, and so the median is taken as the average of the 2 middle numbers. Let's look at an example. Consider the following data. Let us first sort the data from least to greatest. So taking our data that we have here, 2, 3, 3, 4, and then 6. Notice here that we have an odd number of data points. There's 5 data points. And so the middle value is the median. It's 3. In our next example, notice that we have 6 data values, an even number. Let's start again by sorting the data from least to greatest. 2, 3, there's another 3, 4, and then 6 and 7. Notice here that since we have an even number of data points, 6, that the median is going to be the average of the 2 middle values. Recall when you're looking for the average of 2 values that you're going to add them together and divide by 2, which I believe should be 3.5. So we will take 3.5 as our median. Now, there are some advantages and disadvantages that we would like to think about when looking at the median. First, it is easy to compute. It is also not affected by outliers. It is best for data that is skewed. This means that it is a resistant statistic. It is because it's not affected by extreme values in our data. Disadvantages of the median is that it's less universally understood, and it's hard to use in theoretical results because there are no formulas. There's just a list of steps we use to calculate the median. Okay, this about covers all the definitions for section 4.1. If you have further questions, be sure to review the example videos that follow or ask your instructor.